Project management tools. Project execution and control. Project management tools. Effective project management is not only a desirable skill but a fundamental necessity. The sheer volume of tasks, interconnected dependencies, resource constraints, and tight deadlines inherent in operational projects demands systematic approaches. It is where project management tools become invaluable. These tools, ranging from simple visual aids to sophisticated software, provide the framework and mechanisms to plan, execute, monitor, and control projects efficiently. They empower operations managers to gain clarity, identify potential bottlenecks, allocate resources optimally, and communicate progress effectively to stakeholders. Without such tools, even well-conceived projects can quickly become chaotic, resulting in missed deadlines, budget overruns, and operational inefficiencies. Purpose and objective. The primary purpose of project management tools in operations is to enhance the likelihood of project success by providing structured methodologies for planning, scheduling, executing, and controlling project activities. Improved planning and organization, to facilitate the breakdown of large projects into manageable tasks, define clear objectives, and establish logical sequences of activities. Enhanced resource allocation, to enable efficient assignment of personnel, equipment, and materials, ensuring optimal utilization and avoiding over- or underallocation. Effective scheduling and tracking, to create realistic timelines, monitor progress against established benchmarks, and promptly identify deviations. Risk identification and mitigation, to help foresee potential challenges, dependencies, and bottlenecks, allowing for proactive measures to minimize their impact. Streamlined communication. To provide a platform for project teams and stakeholders to understand project status, roles, and responsibilities. Data-driven decision-making, to offer visual and quantitative data that supports informed decisions regarding project adjustments, resource reallocation, and problem-solving. Gantt charts. Gantt charts are visual project management tools that display project schedules in a clear and organized manner. They provide a clear, graphical representation of project tasks, their durations, dependencies, and progress over time. Their primary objective is to enhance schedule visibility, facilitate task tracking, and facilitate communication regarding project timelines. Gantt charts, process flow. 1. List all project tasks, break the project into discrete, manageable activities. 2. Determine task durations, estimate the time required to complete each task. 3. Identify task dependencies, establish which tasks must be completed before others can begin. 4. Assign tasks to resources, allocate personnel or teams responsible for each task. 5. Visualize tasks on a timeline, each task is depicted as a horizontal bar, with the length signifying the duration. The position of the bar illustrates its start and end dates, while connecting lines represent the relationships between tasks. 6. Update progress regularly. As tasks are completed, the corresponding bars are shaded or marked to indicate the completion percentage. 7. Practical example. For the lean manufacturing cell implementation, a Gantt chart would show design phase, 3 weeks, followed by equipment procurement, 8 weeks, and facility modification, 5 weeks, running concurrently, then equipment installation, 4 weeks, after both procurement and modification are complete, and so on. The chart would visually display the entire project timeline, highlighting concurrent activities and critical sequences. Critical path method. The critical path method identifies the most extended sequence of dependent activities within a project, referred to as the critical path. The primary objective of CPM is to determine the minimum time required for project completion, identify critical tasks that are likely to delay the project's completion date, and facilitate the optimization of project schedules. Process flow. 1. List all project activities, similar to Gantt charts, identify every task required for the project. 2. Determine activity durations, estimate the time needed for each activity. 3. Establish activity dependencies, define the relationships between tasks, task B cannot start until task A is finished. 4. Draw a network diagram, create a visual representation of activities and their dependencies, typically using nodes, representing activities, and arrows, representing relationships. 5. Calculate early start and early finish times. For each activity, calculate the earliest time it can start and finish, moving forward through the network. 6. Calculate late start and late finish times. For each activity, calculate the latest start and finish times without delaying the project, moving backward through the network. 7. Determine slack/float, calculate the duration for which an activity may be postponed without impacting the project's completion date. 8. Identify the critical path. The critical path consists of activities with zero slack. Any delay in these activities will delay the entire project. 9. Practical example. In our lean manufacturing cell project, CPM would help identify that perhaps equipment procurement and facility modification are both on the critical path. If equipment delivery is delayed by 2 weeks, and this task is on the critical path, the entire project will be delayed by 2 weeks. Conversely, if training can be conducted 2 weeks later without impacting the overall project completion, it has 2 weeks of slack. Program Evaluation Review Technique. Unlike the critical path method, which typically uses a single, deterministic estimate for activity durations, PERT employs a 3-point estimation approach to account for variability in activity durations. Its objective is to provide a more realistic estimate of project completion time, quantify the risks associated with project delays, and manage projects with high levels of uncertainty. Process flow. 1. Identify project activities and dependencies. This is similar to the critical path method. 2. Estimate 3 durations for each activity. Optimistic time, T0, the shortest possible time to complete the activity, assuming everything goes perfectly. Most likely time, TM, the most realistic time to complete the activity under normal circumstances. Pessimistic time, TP, the longest possible activity completion time, assuming worst-case scenarios and unforeseen delays. 3. Calculate the expected time, T, for each activity. 4. Calculate the variance, sigma 2, for each activity. 5. Construct the network diagram and identify the critical path, using the expected times, T, determine the critical path as in CPM. 6. Calculate the expected project completion time. Sum the anticipated times of the activities on the critical path. 7. Calculate the project variance and standard deviation, sum the variances of the activities on the critical path. 8. Determine probabilities, use the anticipated project completion time and standard deviation to calculate the likelihood of finalizing the project by a specific date, assuming a normal distribution. Project execution and control. Welcome to the heart of project management, where plans come alive and challenges are met head-on. We transition from meticulous planning to dynamic execution and focused control. It isn't just about ticking boxes, it's about steering your project ship through calm waters and unforeseen storms, ensuring it reaches its destination successfully and efficiently. Purpose and objective. The purpose of project execution and control is to effectively implement the project plan, manage resources, monitor progress, and proactively address deviations to ensure the project objectives are met within scope, budget, and schedule. Welcome to the heart of project management, where plans come alive and challenges are met head-on. We transition from meticulous planning to dynamic execution and focused control. Efficiently allocate and manage project resources to maximize productivity and achieve deliverables. Implement robust monitoring systems. Formulate a strategic framework for change management. Project execution and control isn't a linear, one-way street. It's a continuous, iterative cycle that involves constant feedback and adjustment. Here's a simplified breakdown of the core process. 1. Initiate execution, officially kick off project activities, mobilizing teams and resources. 2. Resource deployment and management, assign resources, human, financial, material, to specific tasks and manage their utilization. 3. Task performance and reporting, project teams execute tasks and report progress. 4. Performance monitoring, track actual performance against planned performance using various metrics. Project execution and control, process flow. 5. Variance analysis, identify discrepancies, variances, between planned and actual results. 6. Corrective action planning, develop strategies to address identified variances and maintain project progress. 7. Change request management. Process and evaluate proposed changes to the project baseline. 8. Risk management, continuously identify, analyze, and respond to project risks. 9. Communication and stakeholder management. 10. Documentation and reporting, maintain accurate records of project activities, decisions, and progress. 11. Continuous improvement, learn from ongoing project activities to refine processes and improve future projects. Resource allocation. Resource allocation is the strategic deployment and scheduling of the necessary assets, people, equipment, materials, and finances, to specific project tasks. Optimizing resource allocation in operations has a direct impact on efficiency, cost-effectiveness, and project success. Human resources. This involves assigning the right people with the right skills to the right tasks. Consider individual strengths, availability, and workload balance to ensure a well-balanced team. Effective team leadership and communication are paramount here. Financial resources. Budget control is critical. Allocate funds based on task requirements, track expenditures diligently, and ensure spending aligns with the approved budget. Material resources. Ensure timely procurement and availability of all necessary materials. It involves coordinating the supply chain and managing inventory to prevent delays and disruptions. Equipment and technology. Allocate and schedule specialized equipment and technological tools efficiently. Prevent bottlenecks by ensuring equipment is available when and where needed. Key considerations for resource allocation. Resource leveling. Adjusting the project schedule to balance resource demand with available supply, often to avoid overallocation or underutilization. Critical path analysis. Understanding which tasks are on the critical path helps prioritize resource allocation to avoid delays that impact the entire project. Contingency planning. Allocating buffer resources for unforeseen circumstances or risks. Project monitoring. Monitoring is the vigilant eye of project management during execution. It's the continuous process of tracking, reviewing, and reporting project progress against the project plan. Effective monitoring provides the data needed to make informed decisions and take timely corrective actions. Performance baselines. The project plan, schedule, and budget establish the baselines against which actual performance is measured. Key performance indicators, KPIs, define quantifiable metrics to track progress. Schedule variance, SV, measures if the project is ahead or behind schedule. Cost variance, CV, measures if the project is over or under budget. Earned value. Actual cost. Planned value. Quality metrics, number of defects, rework rates, customer satisfaction scores. Reporting mechanisms, establish clear and regular reporting cycles, daily, weekly, monthly. Utilize dashboards, progress reports, and status meetings to communicate performance. Tools for monitoring, project management software, Gantt charts, burn-down charts, and S-curves are invaluable for visualizing and tracking progress. Project execution and control, change management. Despite meticulous planning, change is inevitable in complex projects. Change management, within the context of project execution, is the systematic process of managing and controlling proposed modifications to the project scope, schedule, or budget. Change request process, establish a formal process for submitting, reviewing, and approving change requests. It typically involves several key steps: identification, documentation, impact analysis, review and approval, implementation, communication, and configuration management. Communication is key throughout this process. Remember, the more you learn, the more you earn. Never stop learning. Life never stops teaching.